Manaswita? Hello dear students. Today we will going to discuss about carboxylic acid in derivatives in session 4. Let us see what are the topics we will going to discuss in this session. One is said to be the what is acid halides. Another is said to be the acid anhydrides. Let us see what is the first one, acid halides. What are the acid halides? The acid halides are nothing but that is acid halides are nothing but these are the derivatives of the carboxylic acids. In this, we will going to discuss about preparations, hydrolysis of hydrolysis and alcoholysis. Another one is said to be the ammonolysis. Another is said to be the reaction with the Grignard reagent. And one more reaction with the KCl. Another is reduction. Another is the bromination or chlorination. See, these are the different topics we will going to discuss in this acid halides. Let us see the first one. How does the acid halides are prepared? Acids halides can be prepared when an acid is treated with the PCl3, PCl5 or thionyl chloride. You remember this PCl3, PCl5 and thionyl chloride are chlorinating reagents. These are said to be the chlorinating reagents. Whenever there is a OH in the in the compound, in any compound, if OH is there, and this OH will be replaced by chlorine. Whenever you use this reagent, the OH will be replaced by chlorine. Let us see this one. Suppose if you take this compound, acetic acid when treated with the PCl3 or PCl5 or SOCl2, you can observe that, what you can observe here, this OH, see, this OH is replaced by chlorine. This OH is replaced by chlorine. See here, similarly, you can observe, here it is. That means you remember what to remember. The OH is always replaced by, what is that compound called, element is called as Cl. You remember that whenever you want to change the OH group by Cl, just treat the compound with the PCl3 or PCl5 or thionyl chloride. Now let us see the other one is another method is, it is industrially prepared by distilling the sodium salt of the acid, that is with PCl3, POCl3 or thionyl chloride. See, this is going to be the sodium salt. Previously it was taken as, what is the carboxylic acid directly, but here we will take the sodium salt of this one treated with the PCl3 or the acetic acid when treated with the thionyl chloride. This is called as sulfuryl chloride. SOCl2 is called as thionyl chloride. SO2Cl2 is called as sulfuryl chloride. In this way, you can prepare the acid chlorides by industrial methods. Okay, let us see what is hydrolysis and what is alcoholysis. Hydrolysis is nothing but reaction with water. What is alcoholysis? Alcoholysis is nothing but reaction with alcohol. Hydro means water, lysis means splitting. Alcohol, you know, alcohol. Lysis means splitting. That is, hydrolysis is a reaction when a compound is treated with water. And alcoholysis is nothing but when a compound is treated with the alcohol. Let us see what happens. First, let us see hydrolysis. Reaction with water gives carboxylic acid. Acid chlorides, whenever it is hydrolyzed with water, simply they give the respective carboxylic acid. When acid chloride, that is acetyl chloride, this is, you know, acetyl chloride, when treated with this one, you will get what is called as the acetic acid. Let us see what is the mechanism of this reaction. Mechanism. See what actually happens. The OH minus of the water molecule will attack on the carbonyl carbon because it is a nucleophilic center because the carbon oxygen bond is more electronegative, it shifted to this oxygen, so that we'll get an intermediate which undergoes some changes. Finally, you will get the carboxylic acid and chloride. Now let us see this. Another one is said to be the alcoholysis. What is alcoholysis? Reaction with the alcohol. Acid chlorides, when treated with what is called as the alcohol, simply you will get an ester. That is actually what is happening here. You have to remember that this Cl and this H will be removed in the form of what is called as the HCl. In this way, you will get an ester. Acetyl chloride, when treated with the ethyl alcohol, you will get what is the compound is called as the ethyl acetate. See, similarly, acetyl chloride, when treated with the phenol, C6H5OH is called phenol, you will get what is called as the phenyl acetate is product. Now, what is the, let us take the mechanism involving in alcoholysis. What is the mechanism is involving? I told you already, the carbonyl carbon in acid chloride acts as a nucleophilic center, and here it is a electrons are there here, and this is going to attack on this center because it is a nucleophilic center, and you will get this is an intermediate, and this intermediate now undergoes some changes. Then what happens? A loss of chloride ion takes place, and you will get the ester. If you take acetyl chloride and ethyl alcohol, you will get this is the compound called as ethyl acetate. Now let us see another one is acid chlorides react with amines to form acetyl derivatives. That is here reaction with amines. When acid chlorides reacts with amines, then what happens? You will get some amide derivatives. These are called as amide derivatives. See, whenever CH3CONH2 is there, we call it as the acetamide. Here alkyl, that is it going to be the derivatives of amides. Now let us take methylamine. When treated with the acetyl chloride, you will get N-methyl acetamide is the compound. N-methyl acetamide is the compound. Okay, and now let us, somebody charted some dullness is there, but it is clear now. Clear gaane kanipistundi naakaithe. Somebody charted evaru Manasita sir side koncham dull ga kanipistundi. Clear gaane undamma, nenu kuda direct live kuda chustunnanu mobile lo. Okay. ఒకసారి కొంచెం బ్రైట్నెస్ పెంచమ్మా మనస్విత, కొంచెం బ్రైట్నెస్ పెంచి చూడు. ఓకే, now let us see, this is going to be the another one. See, acid chlorides react with hydrazine to give hydrazide. These are called as the hydrazine is called as the derivative of ammonia. When acetyl chloride treated with the hydrazine, okay, Masita, I'm continuing. See, acetyl chloride with hydrazine. Hydrazine is a amine derivative. When it is treated with this hydrazine acetyl chloride, here you see what is happening. See, what happened to this cursor? See, this acetyl chloride, you see here, how to remember this reaction? This chlorine and this H simply removed in the form of hydrogen chloride, and you will get acetone hydrazide. Whenever the compound found with the hydrazine, we call it as the hydrazide. Now let us see another one. Acid chlorides react with hydroxylamine to give hydroxymic acids. Now let us see, this is going to be the hydroxylamine. And acetyl chloride, when treated with the hydroxylamine, you will get acetone hydroxymic acid. This is wrongly by mistaken. It is acetone hydroxymic acid. This is not hydrazine. This is going to be the hydroxymic acid. Hydroxymic acid. This is called as hydroxymic acid. Now let us see other one. Acid chlorides react with the sodium salt of fatty acid to give the anhydrides. Acid chlorides, when treated with the sodium salt of carboxylic acid, simply the respective anhydride is formed. Because we are used here acid chloride, acetyl chloride, and here it is a sodium acetate. Therefore, the compound is formed as the acetic anhydride. Again, we have another topic, acetic anhydride. It is a derivative of acid carboxylic acid. There we'll discuss in detail. Now let us go for the another one is the how does the acid chlorides reacts with the Grignard reagent. And here this is an acetyl chloride and this is going to be the methyl magnesium chloride. And what is happened here? Can you recognize what is the reaction that going to happen? See this Cl, this MgCl and converts into what you will get the compound is, see, magnesium chloride, and the compound you will get it is a ketone because it is a ethyl, this is a methyl, therefore ethyl methyl ketone. Or another way, how many carbons? 1, 2, 3, 4. This is going to be the butanone compound. UPSC name is butanone compound. Now let us go for the another. Acid chlorides react with ethers in the presence of anhydride, anhydrous ZnCl2 to give esters and alkyl chlorides. This is going to be the acid chloride and this is diethyl ether. See here also, can you guess what happened the reaction? One ethyl group, that is from ethers, one alkyl group takes this chlorine and here that is converts into the ethyl chloride. See what is happened here? You will get an ester. That ester is called as ethyl acetate. You will get ethyl acetate. Okay, now come to the another one. Acid chlorides react with alcoholic potassium cyanide to form acyl cyanides, which on hydrolysis gives the ketonic acid. See how does the reaction mechanism or reaction happen. See in the first step, the Cl and K, it will be removed and in the form of KCl. Now this will form, this is called acetyl cyanide and which on hydrolysis, you remember, there is a C triple bond C, N will be there in cyanide and this undergo hydrolysis and this part convert into the acid and this nitrogen part is converted into the ammonia. And this is going to be the what is called as a byproduct and this normally called as the pyruvic acid. Now let us see, this is one of the very important reaction. This is called as the Rosenmund reduction. And what is this Rosenmund reduction? Acid chlorides on reduction with hydrogen in presence of palladium barium sulfate dissolved in quinoline, that is a catalyst and produces aldehyde. See what happened? This mixture, what is that mixture? And this palladium barium sulfate in presence of this one will produce its nascent hydrogen and one hydrogen is taken by this chlorine and another hydrogen is taken by here so that it converts into the CH3CHO and the byproduct is here, that is going to be the Cl. This is a very, very important reaction. Why? Because it is a partial reduction. Suppose in the same reaction, suppose if you use the strong what is called as the reducing agent like lithium aluminum hydride, actually you will get ethyl alcohol. That is going to be the a complete what do you call it as the complete reduction, that will get ethyl alcohol CH2OH. Here this you will get But whereas here, because it is a mild or weak or other one is partial reduction takes place in presence of palladium barium sulfate. Okay, now let us go for the another one. Here, these are the some reactions. That is what is there in the case of acid chlorides. Then let us go for the another one is said to be the acid anhydrides. Let us see what is acid anhydrides. Acid anhydrides may be considered as derivatives of acid formed by the D, that is not D. It is elimination of the one molecule of water from two carboxyl groups. The two groups may belongs to same molecule or it may belongs to the different molecules. Let us see this is the case. Here this is one acetic acid molecule. This is another acetic acid molecule. The loss of water molecule from both molecules, you will get acetic anhydride. This is called as a simple anhydride. Why? Because these two are of the same carboxylic acid. Suppose if you see the one is the acetic acid molecule, another is a propanoic acid molecule. In this case, we'll get another one. This is called as a mixed anhydride. Simple anhydride of two same molecules. Mixed anhydride consists of two different molecules of carboxylic acids. Anhydride is nothing but it is without water. Anhydride is nothing but without water. When water is removed from the carboxylic acid, you will get anhydride. When water is added to the anhydride, again you will get this compound that is the carboxylic acid. Now let us go for the another one is sometimes the two COH groups belongs to a dibasic acid also. What is dibasic acid? If a same molecule contain two COH group, that is called dibasic acid. For example, you see here this is a phthalic acid, that is benzene ring consists of two COH group on the adjacent position, that is at the ortho position. When they lost a water molecule, you will get a phthalic anhydride. And this when a one molecule, a single molecule, when contain two COH group, that is called dibasic acid. And in the case of the aromatic compounds, when they are at ortho position, they will also give anhydrides. Because it is formed from the phthalic acid, this is called phthalic anhydride. Now see here, this is called succinic acid. This is called succinic acid. How many carbons? 1, 2, 3, 4 carbon dicarboxylic acid. By loss of water molecule, you will get the respective anhydride that is called as a succinic anhydride. Now let us see other one. The first member, formic anhydride, is not known as a simple anhydride, but formic acid and acetic anhydride, that is both that acid contain formic acid and acetic acid, they will produce an anhydride which is called as formic acetic anhydride. It is an example for what is that called as the mixed anhydride. See, this is going to be the formic acid, this is going to be the acetic acid, and you will get formic acetic anhydride. See methods again. See another method of the preparation of the anhydrides. Sodium salt of fatty acid, when react with acid chloride of fatty acid, gives acid anhydride. See, this is going to be the acetyl chloride. This is going to be sodium. The same reaction we learn in the acid chlorides also. See this on reaction. How does the reaction takes place? Very simple. You can remember this chlorine and this Na will be removed in the form of NaCl. And here what is we get another anhydride, that is acetic anhydride. This is wrong. This is going to be the acetic anhydride because this is acetic acid. This is also acetic acid derivative. Now this is going to be the acetic anhydride. Now let us take another reaction. By passing chlorine gas over a mixture of sodium acetate and sulfur dichloride and distilling the mixture. See, this is called this is sodium acetate. This is chlorine gas. When passed through the sodium acetate in presence of sulfur dichloride, this reaction also produces the acetic anhydride. See another one. When a fatty acid of high molecular weight is distilled with acetic anhydride, the corresponding acid anhydride forms. Acetic anhydride is nothing but removes the water molecule. Means here acetic anhydride acts as a dehydrating agent. It removes the water molecule from here, and the respective anhydride is formed. Let us see one more, another method. Acetylene is passed through the glacial acetic acid in the presence of mercuric sulfate to form acetic anhydride. And here this is going to be acetic acid. This is through this acetic acid, when acetylene gas is passed by in the presence of mercurous sulfate. This is mercurous because it is Hg2SO4, and you will get an intermediate compound which is called as ethylene acetate. On heating, you will get the compound is acetic anhydride. See, actually, this is the one very important method. The previous methods are important for all your competitive examination. See, the simplest way to prepare acetic anhydride is when acetic acid is treated with the P2O5, that is phosphorus pentoxide, you will get acetic anhydride, and it removes the water molecule. Here, I did not mention the byproduct. The byproduct has no importance, no significance in the case of the organic chemistry. That's why you remember mainly what is a reactant, what is a product, and what is a reagent that is employed in the reaction. Now let us see this one. See another one, properties. Acetic anhydride is a colorless liquid. It is a neutral and it's slightly soluble in water. It does not fume in moist air. It is used as an acetylating agent for the detection of hydroxyl or amino groups. That means you remember in any compound, if OH groups or NH2 groups are there, they can be detected by the acetylation, where there this acetic anhydride is used. And this is also used in the manufacture of certain dyes like the dyes, acetate, rayons, aspirin, etc. See, chemical properties, I already told you, anhydride means without water. Suppose if the water is added, it will give its respective acid. Now let us go for the another one. See, with alcohol, it forms the ester. Always you remember carboxylic acids or acid chlorides or acid anhydrides. Whenever they're treated with the alcohols, they always give the respective esters. See, it is an acetic anhydride. This is going to be the ethyl alcohol. It will produce as ethyl acetate. This is with the hydrogen chloride. Acetyl chloride, that is acetyl chloride, means what you have to remember here, very simple reaction that happened. One H is taken, this H is taken by one compound, therefore that is converts into the carboxylic acid, and here this acetyl group take the chlorine, therefore it converts into the acetyl chloride, and another molecule is the acetic acid. Let us see another reaction with phosphorus pentachloride. I already told you, whenever you use this PCl3, PCl4 as thionyl chloride, you remember they are mainly used for the preparation of the chlorinating compounds. Here, because it is an acetyl group, it is also an acetyl group, and these two will be taken, these two chlorines here, the remaining three chlorines, and this will converts into the what is called as the POCl3. Are you current with that? Okay, now here in this way, POCl3 is formed. Okay, then two molecules of acetyl chloride, another one is the POCl3. And then let us take the other one. With ammonia and amines, acetylation of amino compounds takes place. See, this is ammonia, acetic anhydride amination. This is called acetamide. That means here what you have to remember, this H and acetic anhydride. This is wrongly printed. And here you will get two molecules of what you call it as the, and here it is involves two ammonia, and it loses a water molecule. It loses a water molecule, and you will get the acetamide. See, when it is treated with the ethylamine, you will get one is called N-ethyl acetamide, another is called as the acetyl chloride is formed. See, one more reaction is with aromatic hydrocarbons, they give aromatic ketones. So this is nothing but a Friedel-Crafts acylation reaction. Benzene, when treated with this acetic anhydride, actually here we have to use a catalyst. You remember, whenever a Friedel-Crafts reaction is there, you remember there must be, we have to use aluminum trichloride. That is in the anhydrous condition. Anhydrous condition means what? Anhydrous condition means without moisture. And that reaction, we call it as a Friedel-Crafts reaction. And because it is acetylation is going on, that's why it is called as the Friedel-Crafts acetylation reaction. With aldehydes, acid anhydrides, it will give alkylidenes. This is going to be the acetic anhydride. This is going to be the acetaldehyde. On reaction with these two, you will get ethylidene, acetate. This is the product. See another one with nitrogen pentoxide. This is another important reaction. You remember, this is another important reaction. Acetic anhydride, when treated with the nitrogen pentoxide, you will get acetyl nitrate is formed. Okay, with this, we can conclude this session. In this session, we discussed about what are the acid chlorides and what are the acid anhydrides, how they are prepared, and what are their chemical properties. Okay, with this, we conclude this session. Thank you for watching and see you in the next class.